Hi. Hi, everyone. Um, it's our second webinar about programming in Scratch. And we will be going today through first steps how to program robots, our RoboKit and lab. If there are any questions, you can always ask, and of course, based on my experiences, the best if you could just write a message in the comments. And of course, it will be easier then for me to follow them up. The first webinar was an introduction of our products. And today, just today we just start programming. So actually get our hands on. Let me just go through a really first introduction of what is Scratch and how programming in Scratch is happening, and then we'll just do some hard work. Let me just share my screen. Yes, so I prepared a small presentation where you can actually check, which you can actually check later on. So, ROBBOs and basics of programming in Scratch. What is Scratch? So it was developed by MIT Media Lab about a decade ago, and was since really popular among, I would say, technically and not so technically oriented public. And the ones, majority are the ones who just want to start learning Scratch. It's really interactive programming, since it is the graphical language, and a lot of people concentrate in Scratch on game design. And it's since it built with a lot of different animation, we could children in particular can do whatever their imagination let them do. We'll dig into Scratch a little bit deeper later. The basics of Scratch is that it's designed for children from 5 to 6 to 99 years old, as long as they can read. And it encourages problem solving and creative and abstract thinking. And children can work collaboratively. It is used, as I said, all over the world and in more than 150 countries, and it is translated into 4 different languages or more. So basic scene or interface of Scratch programming is seen on the picture. So there is the scene where you can find different sprites. Sprites are the characters in Scratch. So right now on the pages, you can see the cat, which is actually the symbol of Scratch and the logo of Scratch. It can be whatever. Then there is a upper part, groups of comments. They all are color coordinated. So wherever you see the task or example, you can complete it without even understanding some of the or where to look for some of the basic comments, but just knowing the color of them. So then you can find the file, and then you can find those comments. Right now, under the group of comments, we have RoboKit group of comments. So they are green as the Robo green, and we have also the lab comments, for example, if we want to use it with our lab. Program creation zone is where you actually build the programs. This is the where the magic happens and a lot of storming, like what, where, and of course it needs a little bit more of your creativity and creative thinking, because as in Scratch, as in robot programming, everything starts with a simple code, and without you knowing what you want robot to do, or without you knowing what you want the sprite to do, it cannot do anything. It just waits for your commands, like a genie. So then let's move a little bit left. Under the scene where you can see the cat, there is a panel with sensor values. So these are particularly designed and incorporated for the robot and lab. So basically a robot kit and lab. There you can see the sensor values. With the robot, you can see also the treatment meters, which are built in our wheels. And then you can see start button, which you can find on the body of the robot, and 5 places for different sensors. With the lab, there are 5 programmable buttons and 3 built-in sensor: light, sound, and a slider, which is a resistor. Sorry. And then sprite scene and editing zone. So yes, as I mentioned, it's about game design and about using your imagination and creativity. So you actually can draw different screens, different scenes for your sprite. If you, for example, want to use laboratory as the joystick in the game, so then as a character you can use one of the sprites which are offered by the Scratch. ROBBO Scratch and Robot Kit. ROBBO Scratch is Scratch version which we updated a little bit to work with our robots. It can be easily downloaded in the robot.world, from robot.world, in our apps file. There are 2 options right now for the Mac and for the Windows, but we have right now already ready the Linux version, and it will be uploaded shortly. Both of our robots, Lab and Robot Kit, are coming with 2 quick guides. Oh, each of them has 1 quick guide, but of simple comments and some of the instructions of how connecting robots and how start programming using sensors and what parts do we have. We'll go through that together. So that if something isn't clear, should be clear after this session. And so the first program which we suggest is just starting moving robot, actually. So you have to first pick up one of the blocks that will tell robot to initiate the program. So it's actually with your microwave or with your coffee machine or whatever electronic device do you have to tell it to initiate the program. So for example, with microwave, you push the button by first choosing the program and then start button. So let's see this block as the start button. When arrow key pressed, so when the button pressed. Then we set up the movement direction. I always give an example to a little bit more of grown-ups and the ones who have driving license, that driving robot, a let it drive, is like driving manual. So car with a manual transmission. So before you hit the gas, you have to set the clutch either forward or rear. So the same thing works for robots. You have to first set the movement direction. Funny enough, 75% get it wrong, like first 2 to 3 times. So the first and initial block they use is the motor, which Don't ask me, I don't know why, but the grown-ups do that all the time. With children, though, it's easier. They get it right away, most of them. And then, of course, we hit the gas and we turn motor on. Here is an example of motor on for 1 second. You can also limit it to steps, or you can let robot move forever with just the block called turn motors on. I'll show you later. Then RoboKit and sensors. That is where fun began or begins. The robot has in the package, as I already told you, LED, a flashlight, light sensor, touch sensor, proximity sensor, and 5 line sensors. So altogether 6 of them, and 1 for our technically oriented I would say future hardware designers. We have also some parts for the do-it-yourself sensor, or extra parts for the other sensors if something goes wrong and you break them or they scratch or something you want to do. So the RoboKit can contain simultaneously up to 5 sensors. There are 5 places for those sensors. They all are numbered, so you will never get it wrong. So, and then all the parameters, all the information data from the sensors can be seen on the panel, robot panel, which you can see on the right, where it's written like in the slides right now. It's on the right, but actually it's on the left in the Scratch. So there's a trip meters left, right for the wheels. Then there are sensor places. So you can see that there are small blocks. There are 1, 2, 3, 4, 5 them. So when you want to use one of the sensors, you have to just click on that, and you'll see that it's initiated, the connection is in, and everything works perfectly. You can of course have them all 5 at the same time, but they will be showing different numbers if they are empty, because the connections are open. So it means that the robot reads all the time all the data which comes in. So it's not that pretty, I would say. So keep it simple, pick up the one which you use and just use them. Creating simple projects. This is really simple, and this can be repeated in different ways. So I'll just go through it, and then I'll have a few minutes for us to actually do it together. So don't worry. If you want, you can just, if you want, you just can skip my explanations up to the point where I'll do workshop. It's for the users who are watching it in record, but if you can wait, please wait. We'll do everything together. So if you have questions, I can answer them at the same time. And so the sensors. Here is for this project we'll use the same program which was shown above. So when the up arrow key pressed, we set the direction, remember manual, and driving manual, we hit forward, and then for 1 second. So, but for now, for example, in this case, we will need to have a condition. Condition which can helps us to use the data from the sensors. So, and if we right now we will use the touch sensor, and the program says that when the B key pressed, and really important, if you have several programs at the same time designed, use different signs for the program. So for example, you can see that I have up arrow for just moving 1 second forward, and I have a B key from my keyboard to initiate program with the sensor. So if you have 2 Bs or 2 Cs or 3 As, the robot, as any other electronic device, won't know what you want from it to start doing 3 programs which run simultaneously. It rarely happens. Then we have the wait until. which you can see, and we use the block, which allows us to use different data. So we included robot sensor 1, and it means that the robot sensor in position 1, which should be less than 50. So it means our sensors always jump from 0 to 100. So the same as with light sensor, the same with the lime sensors, for example, and touch sensor. So when it's really sensitive to the movement, so I would say 50 is a good thing. So if it hits something, or if something hits now, like as it's written, if something bumps into the robot, it will move back a little. So it means like giving away. Wouldn't it be nice with our cars? The same program, but unfortunately not that easy. So without jumping into the lab programming, let's do a couple of projects with the robot kit, and then go into the lab, because there will be too much information and I want you to check out the actual programming environment. So this is the programming environment, which you can probably see right now. And here you can see that I have already connected two labs and robot. Actually, let's start from the very beginning. I'll show you where to download the app, and then what to do when you have to connect it for the first time, and then we'll start doing it. Okay. So first, we need to go into the web page called robbo.world, and in particular the apps, as I said. Here you can see two different programming environments, and we are going into the Scratch right now. So guys, the website is still developing, so a lot of information is coming in. Just need a little bit time, and please wait patiently. So here we have two options right now for Windows and for Mac, and I use Mac right now, so I would download Mac. So download happens easily, but sometimes for Macs, for example, there are restrictions of downloading something from the internet. So the easiest way for you to actually go through that is going into the your system preferences and security check. There you can follow all the instructions which are given, so I won't go into details right now. A lot of tutorials are found on the internet, and you probably can follow them. With Windows, there could be the same problem. So the same thing, system preferences, the security settings, check out that you allow your computer to download files from the internet. Then you just open it up, follow the instructions like normal setups, and open up the program. So the program opens up like that. Now you can see the control panel, which we developed ourselves as well to be user-friendly, as we try to be. And you can see that for me right now, a robot laboratory number 18 is connected with the firmware 3, and then ROBBO is 98 found also. One thing which I would like you to show right now, I will disconnect the robot, and you see the control panel starts looking for the robots. It will find laboratory right now because I didn't disconnect it, but the robot is not connected right now, so I cannot. So that's why I have to update. Now I will just update the lookup. So we opened all the ports, pairing, USB. Oh, really strange. No answer. Let's check again. Close the port. Yeah, I switched off laboratory. It didn't want to work with me right now. So if you see something like that, you see no answer. So the first initial thing would be like, what's happening? So I would say that it happens sometimes that the products which you receive, they're coming from the factory right away. So, and they are not programmed, they just have their own IDs. And for the program to actually get familiar with the robot, we need to update firmware or upload it. So you can pick up whatever COM port which you see and try to, like, if it asks like update firmware, you press yes. It shows you something like that. So it sends a lot of information to the robot for it to be really, really nice and tell its name. And usually name you can find on the tummy of the robot. So just to compare, if that, for example, right now I have robot rob R1196, so it should recognize rob R1196. So port opened. Yeah, 96. You guessed right. So now we have robot connected. We don't have laboratory connected. Let's see what happens with laboratory. It makes noises sometimes because we have the sound sensor. And we need to do a new lookup because we connected the new device. Now we are talking, and now both found, and I have laboratory 1118, and it is 1118 there. So everything works, and then you can just close it or by pressing exit or here the cross. The thing is that it will never disappear. It doesn't go away. If one of the robots will be disconnected, so they will be automatically, or the panel will be automatically updating itself and looking for the device. You can always return it by pressing the green light on top in the main bar, like menu bar in Macs. But in the Windows, I know for sure it is actually lower in the low menu bar, and on the right where you can find like the place where you see or safely you can safely just take out the memory sticks. So it's there, the same sign. So if you'd get lost, look there. So now we have the programming environment, and you can see the numbers are jumping here because of the light sensor is reading light, and the sounds can get a lot of information from me speaking, and the slider is actually not moving because I'm not moving it, but now we are moving. So, and all the buttons are false for the laboratory just because I didn't press them, but you can see if I press them, they are changing their false to true. If you are not comfortable to work in English, you can change language here. Right now, with the robots, we have English, Russian, Finnish, and Swedish. The translation takes half an hour, so we appreciate feedbacks, and based on the feedbacks, we update our languages. All the other languages, which you can see like a lot, they work with the sprites and with the Scratch in general. But if I, for example, pick up right now German, you can see that not so many things change in this area, but a lot of things change here in this, because it those files, they were translated. Ours still need translation, and we do it ourselves with, of course, native speakers and teachers in particular. So let's go into programming. A lot of talking. Robot sensors, trip meters and sensors are here. Start button is here. So if I press it right now, you can see that it changes true to false. And I have sensor 1 position picked up right now. If I switch it off, it doesn't show me anything. If I switch them all, they will show me some parameters with numbers which are inconsistent, and this is because all the ports are open, but I don't have any sensor right now on top. So as it was in the presentation, we'll go into programming a basic program of moving robots. So when we press up arrow, we have to make it move forward, right? One little thing which I want to mention to everyone who is dealing with RobotKit, please, in the beginning, make this little simple program when space key pressed, turn motors on and stop all. The hat with the signs to start the program is in the events. You can see based on the color. Turn motor off can be found from the robot file, and stop all is in control panel. So stop all. So it means that everything will stop. The robot will stop, everything will stop. It happens accidentally. For example, if you just press once to the turn motors on, it will go forever forward or backward depending on the previous project it had, but it will be really, really hard to catch it because they are super fast right now, robots, and if anything happens, just space. If I press it, then everything should stop. So let's get to our program. When up arrow key pressed, we go to set direction. Remember, we are driving manual, and we go forward. We turning motor on for 1 second. You can update the number here in each and every block where you can see white space. You can use it for numbers. So in Scratch, you can use whole numbers, or you can have them with decimals, but this separation happens by dot, not by comma. Dot, remember. So 0.5, for example, if I want, it is 0.5, not 0, 5. So, and then if you press your arrow up, I press mine, and you probably will hear a noise, robot making noise. Yes, my robot moved forward 0.5 seconds. You can try it yourself. Right now with your robots, I'll move forward a little bit with explanation. So in Scratch, which is, I would say, a magic power which Scratch has, you can always copy your program, and you can do it by pressing Shift and left key on the mouse, and it will offer you to duplicate, delete, add comment, or some kind of help. So you can duplicate the program like I did and move it whenever on the screen, this part of the Scratch interface. But as I said above, always change the sign, because we cannot have two programs right now with the same sign. So down arrow, let's say. And if I forgot to mention, I'm mentioning it right now, the direction can be changed from here. So it's either forward, backward, we turn left, or we turn right. So right now, if logically thinking, if I press down arrow key, I would like to go backwards. And if I do that right now, I can say that, yeah, robot moves. Yes, so the programs can be initiated by the key which was identified, or by pressing the whole program, and it will become, it will have a yellow glow. Yeah, you can see the sound. Or there are other options. For example, you can have each and every key which you have on your keyboard, apart from the F1 and other multifunctional keys. Yeah, you see, my robot is moving every time I press it. So you can do it yourself with the robots at home by just copying these programs and developing more, turning left and right. If you want, I would give you a hint, one hint. If you want to change the power of the motor, you can do it whenever, because it doesn't influence much on the performance if it is before, after, or in the middle of the program. I usually put it in the beginning because robots moving really, really fast, and I don't like when they are jumping when there is not so much space, especially on the fairs. When we are at the fairs, it's annoying when they start jumping, and our customers don't appreciate jumping robots much, but they like moving robots. So like, for me personally, 50% is enough. So if I do again, now it's a little bit slower, but it looks nicer, the movement. And the second program is using sensors. So I will have a touch sensor. The touch sensor is identified by the icon with the hand and the point finger pressing. Looks like a button, but like it's kind of a touching something. I would put it as in the instruction on our quick guides in the first position, which is right in front of the robot, opposite side of the USB cable, and I will switch it on in the panel. So right now, as you remember, if I will show you, if I take the sensor out of the place, it starts reads. I'll show you some numbers. So the connection is open. Now I'll put the robot there. It's now the closed, so the actual sensor is in the place. And if I press sensor, the numbers change. Right now I'm pressing the sensor. Yeah. So now I want to build a program for the robot that it will move backwards if something bumps into it, like for example cat or another robot. It happens sometimes, and for that I will need another key here. So what was in my example? Was it space? I cannot use unfortunately space, but because I used it already for turning everything off, but I will use my A key on the keyboard. And for now, we will need a condition, as it was said. So the robot needs to wait until something happens, until we use, until the sensor reads that there was a collision with another object. Here you can see actually already hint what kind of block can fit into this small window. And this kind of window can be found from the operators. So here you can see the small hint. So we are working in particular with these ones. And if we think about the touch sensor, so it's touching, so it means that the numbers are growing. So it means that as soon as the sensor is bigger something, or the sensor value is bigger than something, the robot has to do the movement. Here it is all. You can always change the this value, the sign from the using shift and left button. So you can change it to equal or to the less or larger than, bigger than. So we can use whatever right now. Actually, it depends like on the position where you put the sensor values. Sensor values, since they belong to robot, come from the robot file, and we are talking about the values like a sensor. So robot sensor 1, robot sensor in the position 1, and we have position 1. We can put whatever, but we need to know, like, we need to be sure that we actually use bigger than, but not smaller than. So in this case, we put it here. If I change the sign, oh, sorry, for example, like that, so it means that you have to change the position of the robot sensor here. Oh, vice versa, just for the ones who are not aware of that. And here, as I said, white spot, so we can put the value. So I would say 50, because you can see it jumps really, really fast to 90, 90 and over. So let's use it. And we use our previous command, set robot direction and turn motor. So we can actually take it from there and move it here and change the direction as we agreed to have it backwards. So if I'm right now pressing A, I have to check, pressing A, you can see the glow. So it means that the program started, but the robot doesn't do anything because it waits until it's the sensor value changes. So if I change right now the sensor value, have you heard this sound? It started moving. The really interesting thing is that the program stopped because it was fulfilled. The condition was fulfilled, it did what it had to do, and the condition was like, we didn't have to do anything. But the hint is here. If you want it to work forever and ever and not switch off every time it touches something, I would say to use the loop, forever loop. So it will do forever and ever. It will meet the condition, do what it needs, and then it will wait again for the next happening. So let's try it again. It's glowing. I press once, the glow didn't disappear because it does it forever. I press it twice, it does it again without disappearing. Just for future, if you would like to have the visuals of the robot moving from my side, I would try to figure it out how to make it work. But if it is not necessary, if the programs is enough for you, then let's keep it as it is right now. And to stop the program, I just press space and the glow disappears. So how does it look? Is it good? Is it bad? Do you like it? Do you enjoy it? You can move with, for example, other programs. Of course, I understand that some of you will require some hints. Please, like, guide us in the direction what we can do more. Or right now, my robot moves back and forth by, like, if I use touch sensor. Well, honestly, in the first 15 minutes when I was introduced to robots, I made out of it working robot vacuum cleaner. Of course, it cannot vacuum, but still it can move around the house, and it can actually avoid bumping into the spaces or people or different objects. So I would recommend you to start with that, or to start with the looking at the electrical devices which you have around houses, and try to actually think about what kind of programs is built into those devices, like how the light in the refrigerator switches on. There is a small mechanical they have done a small mechanical function for the light. It's usually, if it is not too fancy refrigerator, so you have just if you open the switch clicks, is released, and then the light is on because the connection is on. So since we have a LED, you can do that by connecting the touch sensor and the LED, for example, Or if you have a fancy refrigerator and it has the other sensors, why not to think about the having those? Like, what could it be? Think about it. Try to use your imagination. Try to replicate those. For example, the new cars which have a light sensor and they can adjust their light based on the conditions, weather conditions, or the day of the time of the day. So, for example, why not to connect light sensor and LED and try to build the program there? And you can do as many as you want. For example, you can always save all your programs by picking up file, save as. I would suggest to create your own file where you can have all the programs saved, and whenever you do something and you want to go back, you just go open. And for example, I have ROBBO Scratch programming, and I have different element programs already created for today, actually, right before our meeting, and like a couple of months ago. For example, Elementary Next has all the programs which will show you how to connect arrows with the movements of the robot. It always asks you if you want to replace current project. So if you didn't save it, please cancel. If you saved it, okay. You can see what happened. So I have, again, the elementary with the left, right with the setting power, and then I have the touch sensor in the position 1. I can give you a sneak peek of what we've done on some of our events. You can try to copy them at home and see what happens. And if you want to share your experiences, you of course can do that, for example, in YouTube or by commenting to the in our YouTube channel. So, for example, I had let's just jump into that after I introduce the laboratory, because I have like a really classical example of connecting laboratory and robot, and I'll show you a little bit later. So let's go into the presentation about the laboratory. I right now actually noticed that the screen didn't show much, and so I will show you again a little bit faster what I went through, so that there are no questions, or if they're coming, you just try to connect the picture with the screen. Sorry, I'm like really unprofessional in that area, so I'll try to be quick. So again, this is the environment. This is the sprite I showed you. This is the panels, and here we choose the sensors. I have sensor in position 1, the touch sensor. The numbers are changing here. The laboratory is here with the buttons. I'll show you with the laboratory more, so I'll know where to go. But here are the comments which I've been showing you, and I hope they've been shown in your screens, but if not, please accept my apologies. And here are all the files where you can find the color coordinated programs. And here is how you can duplicate, delete, or add comment for each program. Here you can choose the keys. Here direction, and the white spots are for the numbers. Okay, so let's jump into the laboratory so that I won't take much of your time. Hello again, and here is the other. Just a second. presentation. Yeah, I'm sharing it with you. So ROBBO Scratch and Laboratory. Laboratory is a little bit easier product and robot. It is most applicable in the game design, using as a joystick, or for collecting environmental information and learning how the voice is changing, what are the sound waves, what are the light waves, how the light is distributed around the environment you are in, and etc. etc. By the way, if you are interested, robot cannot speak, but laboratory is able to sing, and you can create different, really magical, or compose different magical music. Like you do need to know a little bit of the like sheet music, but let's use it in our next webinars. For the elementary entry, connecting a laboratory and a sprite, you would need to use the same conditions as we've been doing them, using them in the robots. And as I showed you, you can use forever block to run the program in a loop. So if condition is met, it will not stop. It will just continue waiting for another condition to be met. So right now there is a program. We pick up the conditions. We use lab buttons. We pick up them from the button file, and then since we use sprite, we go into the sprite files, and you can see here is a bright blue, so I will show you where to find them. So now we just, with the button number 3 and button number 1, which are numbered on the PCB of the laboratory, on the body of the laboratory, you can find all the numbers, so you won't get lost. We just make the sprite move. Give you a hint that the same way it works for the robot, but instead of using the sprite blocks, you have to go for the robot blocks, and like actually use the initial program which I showed you, like set direction and turn where to turn. The buttons, as I showed you, can be found from the lab panel, which is on the left, and the numbers can be read there when the lab connected. And it has 5 of them, with the light and sound center and the variable resistor, which is a slider. Before we jump into Q&A, now I'll show you a little bit more we'll show you a little bit more to the programming, actually, of the laboratory. Now I'll change the screen again, so I hope it works this time better. I'll share actually entire screen with you, so there will be no mistakes. Oh, not a good idea. I will stop sharing and we'll return to the Scratch. Sorry, guys. So again, I'll show you. You can download the programs from the website and from the apps, Scratch, Windows, and Macintosh or Apple. Then we can jump into Scratch. I will show you the panel, which I wasn't able to show you before. You can see here. I'll just check that you can actually see that. Just a second. the control panel. Yes. So it's really hard for me to right now to operate with the control panel, but I hope that you will be able to, based on my guidance, set up the connection with the control panel. We can give a feedback to the Google Hangout on that. But let's go into the actually Scratch so that we won't lose much time. I will you can always delete all the programming from here this way by just moving it. Yes, like that. And let's repeat the program which was shown in the presentation. So we use again the key. Let's use A for that key. We'll use from the control the forever loop. We will use condition if, and we will use it twice. So instead of just duplicating, I'll just put them here. And then lab blocks can be found here. So we use lab button number 1 and we use lab button number 3. Yes, that's correct. And the lab button number 1 is on the left of the laboratory and button number 3 is on the right. So accordingly, as I said, we go into the motions, the sprite motions. Here you can find motions for the sprite. Most of the things which are not for the robots can be found here. So for robot and lab particular here and others from here. So sounds, as I mentioned, the sprite can make its own sounds, and if we want sound from the lab, so we are going into the notes from the lab. And the same thing if we want to have for example, LEDs on, so we use them here on the lab. If we want to move cat, we use movements here. For the robot, we use here. So motions, and we move to the right when the robot button number 3 pressed, and to the left if the button number 1 pressed, correct? So in forever loop, I add 2 conditions like that, and I connect. So it should work. A good example of how to check that everything works if you are not using this flag in your program as a sign, which you can actually use from here. You see, if you don't use, I use it just to check that program works, that everything is fine. And then I press key A, and I check what happens if I press button number 1. And what happens if I press button number 3? So the cat moves. The movement can be noticed in the far right, left corner. Sorry, I have problems with the directions. Never followed once. So you can see the cat is moving. To make it fun, I'll show you now a little bit of the programming which I did. I don't go into the more into details in the programming of the games in the Scratch. There are so many books written, and you can, for example, check Derek Breen's books about Scratch and programming in Scratch. Everything can be adapted and updated, used with robots and laboratories. So just check them out. We didn't want to go into those details because there are a bunch of information, like millions of books written. So pick up the one which you want, and if you need guidance. If you don't need guidance, just dig into it yourself. I'm learning by doing so. Really hardly ever try to find guidance in the books, but I love also use those to a little bit open up my mind and jump out of the box. And here, open, I will show you programs which I did myself for the cat. So I have two programs right now. Let's go with A first. It is also in forever loop. It has the condition that if the slider is greater than 40, so you can see slider or in the lab panel is greater than 40, so then the cat will show up and say hello. If the lab slider is less than 40, then the cat will disappear with the for 2 seconds. I can put there bye, for example. Bye bye. Let's use the capital for the first one to be correct. Oh, sorry. Yes. As with all empty spaces, you can use whatever. You can write different languages, use different languages. You can write whatever you want. It can talk, it can say sentences. You can create communication between sprites. And by the way, if everything works finely, now you can actually see how many sprites there are. A huge amount. For the hungry people, there is even donut. If you are a fan of fortune cookies, you can have one. If you are a Nemo fan, like Finding Nemo, yeah, you have your own variations of all the fishes. You can be a lamp if you want, honestly, whatever. But we'll stick to the cat. I'll let you think about it more. And let's check the program A. I press A key, we are glowing, and the cat's telling me bye-bye for 2 seconds and then hides. So really polite cat. And if it comes back, it says hello. And you can see how it changes the value of the slider. Oh, you see what I did? I pressed reset. So it means that the connection was stopped, and that's why I had a control panel in front of me showing me the connections, like what's happening with the robot. So program is A is in. The slider changed the values, so if I move closer to 50, the cat doesn't do anything, but if I hit less than 50, 48, 60, yeah, 40, less than 40, it disappears and says bye-bye. Really, really nice cat. Let's bring it back. Okay, I brought it back. I switch off the program right now. You see what I didn't do? I didn't have a space and stop all from the control. So I would recommend to do that with the cat as well. So then I can do other programs. So let's do B, press B. And now we use this almost the same program which we built together, but now let's see what happens. The cat changes its color. Isn't it cool? We have a disco lights right now. And if I turn back, just even for 15 degrees, it clears all the graphics. So you actually can program that it will change its appearance. So you can jump into donut, piggy, then lamp if you want, cookie, whatever your imagination allows you. And without further ado, I will present you one comment which I won't do together with you, but I want you to repeat yourself at home, like your homework for today. And if you're lucky, if you want, you can share it on our YouTube channel, your answers. So here is my program. Yes, they are ABC program, 3 ABC programs. They both are for sensors, and this one for A is really similar to what we did already with the robot today with the touch sensor, but these two B and C are connecting laboratory buttons and laboratory slider with parts of the robot. One slider works with the LED, and then buttons work with the motion, robot motion. This is just an example of a basic collaboration between lab and robot. With the C program, you can build your own electrical car, which you can control through the joystick laboratory. And with the B, you can control the slider, with the slider, the LED. Here, position 5, so it means that it should be in the position 5. You can choose whatever position you want out of 5. So it's up into you, in your hands. And please remember, pick up those positions. For now, this is all for today. Please, if you have further questions, I'll wait for a while for you to finish it. But if not, then I will tell you goodbye and good luck. Please use your imagination, use the ideas which I provided today. Try to imitate some of the electrical devices which you have at home. It will actually work better than you think. And if you need help, you can always comment under the video or in our YouTube channel, or write us a message at info@robbo.world. We have a book coming out soon. I'm again apologizing for delay, but it will be really cool. I've seen all the exercises, did some of them myself, and they are really nice. But I wish you good luck, and I want to just tell you thank you. Thank you for being today with me, and please comment if there's something you have missed or you didn't get and you want me to show you again, or just tell me what you think. And since I am not a big fan of the this kind of breaks, silent breaks, I'll tell you some examples which you can also try home. Try, for example, use a light sensor and the dark rooms by using the different light or the, how to say, using a dark room, you can actually put light sensor into reading it, and if it's too dark, it can switch off the LED, as an example. We can use the line sensors to go through the maze or go through the track. I would suggest to have tracks built out of the black scotch, or you can just print them on the white piece of paper, or draw them with the crayons, whatever you prefer, and try make robot follow them. It's not that easy as it sounds. It's fun, and it opens up a little bit your mind and how everything works around you. For example, on the crossroads, how the traffic lights turn and why it doesn't work if you press it 150 times. You can actually build the same kind of system with your robot by pressing 150 times the touch sensor, and using, for example, the delay button, where like wait 5 seconds, 3 seconds after that starts. So this is kind of the system which they use in traffic lights, just for your information. I see that there are no questions coming, so you can write them later, and I wish you good luck. Most of my instructions came from the quick guides, but if you have some comments and questions in particular, please write us. We are waiting for the feedback, and if something is missing and something is incorrect, we will deal with that and correct it right away. So all the information is at robbo.world. Follow us on Instagram or Facebook. And let's keep in touch. Thank you. Bye.